Lesson 40, simplifying and evaluating expressions using the power rule for exponents. What I have listed here are some exponent rules that we should already know, and those are things such as x to the power of 0 or anything to the power of 0 is always equal to 1. Where we have x to the first power, that is always where we get that base. It's like the identity exponent. Whenever we're multiplying by the same base, we know that we add the exponents. When we're dividing by the same base, that's what's happening here, we subtract the exponents. And to change the sign of an exponent, we know that we can move it across that fraction bar. So if the negative had been in the denominator, we would move it to the top. So our first example has 2 to the third to the fourth power. So I want you to think about what that actually means. If I had given you a to the fourth power, okay, and I'll even put a in parentheses like they have it here. I hope that you remember that this would mean a times a times a times a, which would be a times itself 4 times. Well, in this case, we have 2 to the third to the fourth power, which means I'm going to take 2 to the third times itself 4 times. So I have 2 to the third times 2 to the third times 2 to the third times 2 to the third. Well, whenever I write it like this, you already know a rule. This is a 3, it doesn't look like it. You already know a rule that it's going to get you the answer, right? Because I'm multiplying by the same base, and when I do that, I can say that I'm going to add the exponents, which would mean that I would have 2, and then 3 plus 3 plus 3 plus 3 gives me 12. Well, do you see another way that we could have gotten 12 without writing all of this out by what you're given here? I hope that you see that you could have instead taken 2 to the third times that fourth to get you the exact same answer, which is 2 to the 12th power. Okay, this is the power rule for exponents, which is whenever we have a power raised to a power, which is what's going on here, we have 2 to the third power raised to the fourth power, all we have to do is multiply the exponents. So the same thing is happening here. I have 10 to the second to the third. All I'm going to do is I'm going to take this outside power to this one, and when I do that I have to multiply. So I have 10 to the second times the third, which will give me 10 to the 6th. Pretend that looks better. I want you to do this last one on your own paper, please. Okay, so this is giving you the algebraic definition of the power property, which they give us x to the m to the n, which is equal to the xmn, where mn are being multiplied. So for example 1, these are the exact same thing that we've just done. So I want you to pause the video and try and do these on your own paper. For A, on example 1, we have 3 to the fourth to the second, which means that we're going to have 3 to the fourth power times the second power, which is going to give us 3 to the 8th power. Final answer. On B, I have z to the 5th power to the 3rd power, which means I'm going to multiply, and that gives me z to the 15th power. Final answer. The power of a product property says that if I have this m, first of all, let's start with, I have the product of xy raised to the m power. That is equal to x to the m times y to the m, because this power has to be distributed to everything inside of that product. Okay, this only works like this. We can only distribute the exponent whenever it's a product inside of the parentheses. If there's addition or subtraction, that is something totally different. Okay, so make sure that you remember you can only take the exponents inside of the parentheses the way that I'm showing you if it is a product on the inside. It has to be being multiplied. So for example 2, what we're doing is we have 3 to the understood 1, I hope that you remember, and g to the 4th. And all of that is being raised to the 3rd power. So what I'm going to do is I'm going to take this third power and I'm going to distribute it to the exponents that are on the inside. So I have 3 to the first was what I had, and I distributed the 3 to it, so I'm going to take 3 to the first times the third, g to the fourth, and I'm taking the 3 to it, so times the third, which gives me 3 to the third power and g to the 12th power. This is my final answer. I want you to try and do B on your own paper, please. And so go ahead and pause the video at this time. On B, what you need to do is the exact same thing that we did on A. We're going to take this power out here and we're going to distribute it to each part of the product on the inside. Now, when I take it to the -4, it's very important that I leave that -4 in parentheses, because if I don't, it's not going to give me the same answer. So what I have is -4, which was originally to the first power, and we're going to multiply it by the 2 that we are distributing to it. Then I have m, which was originally to the second power. Okay, and I'm going to multiply it by the 2 that I'm distributing to it. And finally n, which was originally to the third power, and times 2. So when I simplify this, I have -4 to the second power, m to the fourth power, n to the sixth power. Okay, now that I'm here, I still have a little bit of simplifying that I can do, because I have -4 to the second power. -4 to the second power, I hope you remember, means -4 times -4, which is going to get me a positive 16, and then I'm going to bring down the rest of my answer, m to the fourth, n to the sixth. Example 3, we are going to combine a couple of different things that we already know how to do here, and we're going to start by the rule that we just learned. So to simplify this, I'm going to first have to take this 2 to the product inside, to each part of the product inside these parentheses, and I'm going to have to take the 3 to each part inside of these parentheses. So this 2, which was originally to the first, is going to be multiplied by the second. I have x, which was originally to the first, multiplied by the second. I have y to the third times the second. And these parentheses, even though it doesn't look like it in my problem here, they're touching, so all of this is being multiplied by each other. Okay, so I'm going to continue what I have going on here. I have 5 to the first times the third, x to the second times the third, and y to the first times the third. So I'm going to simplify my exponents at this time. I have 2 to the second times x to the second times y to the sixth times 5 to the third times x to the sixth and times y to the third. Now, at this time, or at this point, I am multiplying all these things, and I hope that you remember one of our old exponent rules, which is whenever we're multiplying by the same base, I can add the exponents. Now, I don't have a common base of 2 anywhere, so I'm going to go ahead and multiply this out, which is 2 squared, so 2 times 2 gives me 4, times, and I'm going to put this number with it, 5 to the third, that's 5 times 5 times 5. 5 times 5 is 25, times 5 is 125. Then I have x to the second and x to the sixth. So I'm going to have x to the second. When I multiply by the same base, I add the exponents. So I'm adding 2 and 6. I have y to the sixth, and I'm going to add that third. So 4 times 125, that's going to give me 500. And then I have x, 2 plus 6 gives me 8, and y, 6 plus 3 gives me 9. I want you to try and do B on your own paper, please. Example 4 says use the formula a equals pi r squared to find the area of a circle with a radius of 2x squared y to the third. So whenever we have a problem like this, we always start by rewriting the formula. So I'm going to rewrite my formula of area equals pi times radius squared. And they say that the radius is this 2x squared y to the third. So I'm going to plug this in for my r. So when I do that, I have area equals pi. And then instead of radius, I always use parentheses when I substitute. So I have 2x squared y to the third, and all of that is being raised to the second power. I want you to go ahead and simplify that on your own. I hope that you have taken good notes and that you have a good night.